Hello and welcome back to the Energy Systems and Management course. I'm excited to have you join me as we explore energy management topic. Whether you're a seasoned expert or new to this subject, I promise you'll gain valuable insights from our discussion. So let's dive right in. The key learning outcomes for this lecture are that we hope you'll be able to define the term energy management and describe the role of an energy manager. As we manage our energy, we'll also be looking at the impact of energy management and its significance. These impacts can be measured through simple but useful terms such as internal rate of return and payback period. Heating a building, illuminating a lamp, running a pump, or starting up a computer requires energy. Energy used in buildings and industrial processes is usually supplied in the form of electricity, gas, oil, coal, or other types of fuel. However, it is then converted into another form that is more useful for the tasks that need to be carried out, including hot water or steam for heating radiators or motive power, and kinetic energy to run a pump to push water around a heating system. Energy can be found in many forms: mechanical, thermal, chemical, electromagnetic, and electrical. These forms typically fall into categories of either heat or work. Efficient energy utilization is paramount, as a portion of energy dissipates during its utilization. The adept management of energy resources is indispensable not only to prevent avoidable waste, but also to contribute significantly to the conservation of energy, fostering a path toward a more sustainable and environmentally conscious future. So what is energy management? The basic definition would involve the control of energy, the monitoring of energy, and the conserving or conservation of energy. And each of these features forms a central part of what it is to be an energy manager. Of the three, controlling, monitoring, and conserving, the most important in many ways is monitoring, because without being able to tell how much energy is being used, it's rather hard to control the energy usage or to tell if you're having any effect on the conservation. It's rather hard to tell if your energy efficiency is improved if you don't know how much energy is being used before and after. There are three key ways that energy can be monitored and therefore controlled and conserved. The first is via sensors like metering. So you might have smart meters in your home, which will show you your daily energy usage. Other sensors can include heat, lights, and even draft sensors, which can tell you where the heat is being used, if windows are being opened, or the lights are being left on. A second option is billing. Your energy bills will tell you how much energy is being used on the site. Naturally, if there is a discrepancy between the amount of energy you are billed for and the amount of energy you think you are using, this needs to be investigated to make sure you're not being overcharged or are expending energy unnecessarily. Finally, there are site surveys. These would include a visit with live sensor equipment, like a thermal camera, which is used to see where the heat is leaking out. Or you could do something as simple as observing staff behaviors, looking at the workshop floor, and seeing how some of the equipment is being used, and whether the energy is being wasted or used effectively. Once you have a good handle on how much energy is being used, controlling that energy usage, and conserving the energy, will follow naturally. Assuming you would like to develop your career in energy management, we can look at what an energy manager needs to be able to do. And given that it covers not only the delivery of energy, but the monitoring of how it's used, and looking at how it could be used differently, it perhaps shouldn't be surprising that it's a very multidisciplinary role. That is to say, it is a job that requires a wide array of skills. You will, of course, need some engineering background. But you'll also need management accountancy and marketing skills to look at the costings, the priorities, and how to present new approaches or report successes. Even if you have an excellent idea for saving energy, it won't be any help unless you can convince the decision makers you work with, whether they are business managers or your co-workers, to adopt them. So the best idea in the world is no good if it's never put to use. So there's a certain degree of pitching ideas that must be involved. There's even psychology. Many habits we've discussed that involve wasting energy, such as leaving lights on or changing heating patterns, are very hard to break. Finding the proper techniques, especially for these behavioral modifications, can be challenging. Finally, there's the problem-solving aspect. Finding a solution to an energy management problem can be very tricky, especially when there are a lot of weighted factors to consider. Even in a purely technical and engineering solution, sometimes the solution can require some very creative non-technical approaches. Cost saving is one of the major drivers for energy management systems, along with environmental sustainability. However, the energy cost savings that are possible are very much dependent on the size of the organization and the sector and organization type. So if it is a very energy-intense organization, say a process like a steel manufacturer, there are many more opportunities for saving significant parts of the energy cost of the system than there would be if we're talking about a business that was mostly office-based. And then it also depends on the size of an organization. So a small office of 5 or 6 people is not going to have a significant enough energy consumption for major reductions to be possible compared to a large multinational, multi-tiered organization. Now, from figures from the Carbon Trust, the general rule of thumb is that 20% of savings on energy bills can be made by managing and investing in cost-effective energy efficiency. So that is to say, energy management systems and energy managers can reduce energy bills by about 1/5. Further savings can then be made 5% further by implementing programs with low or no cost measures. So these are these behavioral modifications, like reducing energy usage from lighting and heating, and behavior changes, like turning the lights off or the equipment off when it's not being used. Note that energy management is an iterative process. When talking about energy savings and cost savings, there are a few useful definitions to use. As this course is not an economics course, we're not going to be going into high-level economic measures, but we can use a couple of simple measures, including payback period and internal rate of return. First, we'll talk about internal rate of return (IRR). This is the percentage of investment that is returned to the investor each year, typically expressed as a percentage. So the example here would be, if the cost of a new boiler was £1,000, and that new boiler saves £200 in gas costs a year compared to the old one, it would have an internal rate of return of that £200 divided by the initial cost, or 20%. The second measure of economic return is the payback period. So the internal rate of return, the IRR, was a percentage return on investment. Effectively, the payback period is a unit of time instead, which is the capital expenditure divided by the annual savings. That is to say how long it will take for the new investment to pay for itself effectively. So if this new gas boiler costs £1,000 again, and has this £200 a year saving, the net payback period is 5 years, because after 5 years of £200 savings, that equals the cost of the boiler in the first place. Now, companies often use these payback periods to decide whether something is a good investment or not. Things with very long payback periods tend to have a lot of risk associated with them because you're effectively borrowing money for a very long period of time before you're going to see a return. If a company is doing particularly well, it might be very happy with any process that has payback periods of less than 3 years. So if the process is going to pay for itself in 3 years' time, the company can be fairly confident that its financial position is going to be pretty good in the next 3 years. It will go ahead of that process as long as it saves a decent amount of money. If the company is getting into financial difficulty, or times are getting tough, that payback period, or the minimum payback period before they'll adopt a new procedure, might shrink down. It might even get to the point where they will only enact policies that have energy improvement figures of 6 months or so. That is to say, it will pay for itself within a year of, or within half a year of being installed. So then only the very even solutions, or only the most promising improvements in energy efficiency, would get approved. Thank you for joining me in this short lecture video. I hope you found the content both informative and engaging. For a more in-depth understanding of the topics covered, please refer to your course handout, which accompanies this lecture video. The handout, prepared by Professor Zandi, contains valuable supplementary materials that will enrich your learning experience. Your commitment to education is greatly appreciated. If you have any questions or need further clarification, don't hesitate to reach out. We're here to support your academic journey. Once again, thank you for watching, and I look forward to our next learning opportunity together.